Ideas don't come with fully formed. It only gets clear when we work on them. With this thought, I would like to extend my heartfelt thanks to Tata Technology in collaboration with Tata Motors and Microsoft for organizing the Innovate program for students. I am Vishal Kumar Roni, representing Teammate 48 from Kalinga Institute of Industrial Technology, Bhubaneswar, Odisha. On behalf of Teammate 48, we are incredibly excited to present our solution on the generative AI theme to our esteemed jury members, where we made TataSafeguard a comprehensive analysis of wiring malfunctions, structure damage, and recommendations for aircraft and automobiles, leveraging real-time analysis from external source. Well, before diving into the more details of the project, I would like to introduce my team members and their contribution to the TataSafeguard project. So, what is our objective and solution approach for Tata Safeguard? The goal of Tata Safeguard is to develop an advanced AI-driven platform that detects structural damage and wiring malfunctions in real time for aircraft and automobiles. This solution leverages cutting-edge technology to enhance safety for users by preventing major errors ahead of times and helping manufacturer manually inspect critical parts during production. It also aims to reduce downtime and optimize maintenance efficiency by offering precise damage analysis, repair recommendations, and 3D visualization of sensitive part nodes using graph algorithm. The solution approaches include data collection and analysis, AI model development and training, real-time monitoring and fault detections, generative AI for repair recommendations, user-friendly web application, and the last, graph algorithm based 3D visualization for shortest path. Let's take a moment to understand what we are trying to build for model development and its overall functionality. Our solution project is not limited to generative AI. Rather, we have leveraged various stages, including training, testing, building, and deploying our models using different algorithms. This allows us to compare and differentiate accuracy and result from training a basic CNN machine learning model for prediction to advanced deep learning based object detection models for by leveraging generative AI for repair assessments. These assessments are provided in the form of prompt to text, image, and video. At this stage, we have successfully implemented a manual process and it's working excellently. However, by the end of the project, we aim to automate this process. Also, we have implemented CAD 3D visualization by utilizing graph algorithm to point out sensitive node and stress point, which can further stimulate signal finding the shortest way through defective signals. Let's talk about the real-time analysis feature. With the integration of a scalable and impactful functionality, our system undergoes streaming analysis and assessment in real time, enabling real-time image and video processing for damage detection, faulty wiring through external sources such as IoT-based devices. Picture this with an example from both the consumer and production sides. Suppose I own a car but have no idea about the conditions of its internal sensitive parts. Over the time, where in a month earlier some parts may weaken and lose their efficiency. This issue often goes unnoticed since they are typically only trackable by mechanics. Now imagine the manufacturer has integrated a real-time image and video processing features for damage and faulty wiring detection directly into the car display. With these systems, the sensitive parts are monitored for signs of weakening and reduced efficiency, helping consumers take time, safety precautions. This proactive approach can prevent major future hazards. On the production side, numerous parts are manufactured during the car assembly. The manufacturers can track and inspect sensitive parts after production using the same technology. Additionally, this system is cloud-based, storing and automatically deleting data every week, ensuring a fresh start up for each manual inspection cycle. So at last, the add-on note and the challenges faced by us for building a Tata Safeguard project. About 70% of our expected work for what we thought during stage 1 is completed. We are still continuing to brainstorm and explore better approaches and features to enhance scalability and impact. We are facing challenges in streamlining all processes at once without relying on the manual processes. Note, manual process has been completed, deployed, and is working excellently. We are also brainstorming and exploring different approaches for CAD visualization to determine the shortest path and identifying the stress point using the graph algorithm. Thank you on the behalf of Teammate for it. Let's innovate and build together.